Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is the database design concepts, and the same chapter, that is chapter number 3, that is the introduction to the SQL. In the last class we have finished with the chapter number 2 and we have started with the chapter number 3 also, and we have covered some topics with chapter number 3. And we have finished with the chapter number 2 also in the last class efficiently and effectively. So let's start with the previous class session what we have covered in the last class, then move to the today's topic, that is the chapter number 3 continue, that is the introduction to the SQL, that is how the SQL functions maintained, or what are the various functions that is used in the SQL. So let's start with the previous class session, that is the yesterday class session. In the last class, we have started with the relational operations. That is, what are the various operations that will be performed on the relation or the relational algebra on the relational model. That is, what are the various relations or what are the various operations that will be performed on the relational algebra, relational model on the relational table or the related tables, right? So this is the relational operation, that is the topic that we have covered. That is, what are the various operations that will be performed on the relational operations. So all procedure relational query languages provides a set of operations that can be applied to either a single relation or a pair of relations. The relational operations can be performed or can be applied to either a single relation or a pair of relations. These operations would be the nice one. That is a These operations have the nice and the desired property that their result is always a single relation. That is, they have the capability that the relation is the single property or the single case that is used. These operations have the nice and the desirable quality that the result is always a single relation. That is, they only produce a single relation, single table as their output. Then this is a relational operation that is used. This is a table that is a result of the query selecting instructor tuples with salary greater than the 85,000. So this is a table, this is a result that shows that giving the instructors information, or giving the tuples of the or the rows of the instructor table where the salary is greater than the 85,000, that is salary is greater than 85,000. And the join operation also allows a combining of the two relations, that is how to combine two relations by merging pairs of the tuple. That is, pairs means by merging the two tuples, one from each relation, into a single table. That is also maintained by using the, or that is also done by using the join operation. In this form of join, which is known as natural join, a tuple from the instructor relation matches a tuple in the department relation. So the join operation is also used. That is also a relational operation that is used to perform the operations on the table. Then this is the Cartesian product that we have discussed, how to make the, or how to do the Cartesian product so that it will be available, or that we will multiply the two objects. And this is a relational algebra that we have discussed in the last class also, that is very important in the database chapter. So this is the relational algebra defines a set of operations on the relations. So it defines a set of relations or set of operations on the relations. There are many operations that will be available on the table, paralleling the usual algebraic operations such as addition, subtraction, multiplication, which operates on numbers. So there are multiple operations, there are multiple, we can say the multiple output comes that will be available in the operations, which operates on the number, just as algebraic operations on number that take one or more form as input and return as output. The relational algebra operation typically takes two or two or more relations, that is, they take two or more tables as an input and returns a relation as an output. And this is one of the example that is used. This is a symbol, there is an example of the usage. There is a selection symbol that is used, there is a selection operator. What is the use? That is how to select the data, or how to fetch the data from the table. So this is a sigma that is used, that is selection. Now select the salary whose salary is greater than 85,000. From which table? That is the instructor table. So getting the salary or getting the records from the instructor table whose salary is greater than 85,000. This says return the rows of the input relation that satisfy the predicate, that is a condition. Then there is a projection that is also used but with the pi sign. So there are two attribute that is finding out, that is project, that is ID and the salary. So output specified attribute from all rows of the input relation. Remove the duplicate tuples from the output. Then there is a natural join, that is how to join the tables. Then instructor and the department, that is 2 is used for the natural join, that is combining the table with the natural join. Then Cartesian the product or Cartesian product, that is denoted by the multiply sign. So this output all pairs of rows from input regardless whether they are on a same value or not. Then there is a union, that is combination of two tables, that is getting the name from the instructor, getting the name from the student. Then we have studied about the summary also, that is the summary part also, that is how to use the summary or how to do the summary, or what is the summary, or what is the crux of this chapter, that is usage of this chapter. So the relation first point says the relation mode data model is based on the table. Then second says the schema of a table, that is a schema of a relation, that is a that defines the logical design of the table, while the instance of the relation refers to its content at a point of time. So what is the relation, or what are the various form, what are the various content at a point in time? The schema of a database and an instant of a database are similarly defined. That is a logical design, and this is what the content are available, or what are the various content that is available at a point of time. Then super key, that is also a set of one or more attributes whose values are guaranteed to identify tuples in the relation uniquely. That is one of the most concept that is also used, that is a primary key, that uniquely identifies a table, uniquely identifies the relations. Then there is a foreign key, that is a set of attributes in a referencing relation such that for each tuple in the referencing relation, the value of the foreign key attributes are guaranteed to occur as a primary key, that is a foreign key. Then a schema diagram, that is also a pictorial representation of the schema of a database, that is how to represent the schema, or how to represent the logical design in a diagrammatical form, that is a schema diagram of the database. Then there is the next point, that is says about the relational query language. So this is a query language, or this is a language that fetches the information from the user, on which or in which user can demand from the or user can ask from the salary from the users. So they define a set of operations that operates on the table and the output tables as a results. These operations can be combined to get expressions that express desired queries. Then next is relational algebra, that provides a set of operations that take one or more relations as an input and returns a relation as an output. That is, there are so many operations that is also available, that is a relational algebra that provides a set of operations that takes one or more relations as an input. There are two or more relations that is available as an input, and it gives the output, or it gives the relation as an output. So takes the input by one or more relation, by one or more table, and return the output, or return the relation, return the table as a output. Practical query languages such as SQL are based on the relational algebra. And these are the review terms that is also available in this chapter, and these are the practice exercises. This is also the exercises, then bibliographical notes. Then next is the chapter number 3, that is the introduction to the SQL. In this chapter we have studied about the this overview of the SQL query language already in the last class, that is how to, or what is the overview of the SQL query language, what is the history of SQL query language. That is, it was first developed by the IBM in the year 1970s, then later on it is improved, and now there are multiple versions of SQL, that is SQL 2008, SQL 2010 to SQL 2009. So there are multiple versions that is also available. And the SQL language has various parts, are divided into various parts. One is the DDL, that takes the relation schema, that is a logical design, how the relations are maintained, that is a DDL, that is a data definition language. Then there is a DML, that is a data manipulation language, that provides the ability to query the information from the database and to insert the tuples into, delete the tuples from, and modify the tuples in the database. So how to delete, how to insert, and how to modify the rows tuples in the database. That is the DML. So one is the DDL, one is the DML. Then there is the integrity, that is the how the integrity will be maintained, or how to include the commands for specifying the integrity constraints. Then view definition, then transaction control, then embedded SQL and dynamic SQL, then authorization. So these are the various parts that is also used in the SQL commands for specifying the access rights to relations and the views. So these are the various topics that we discuss, or that is discussed in this chapter, or that will be discussed in multiple chapters, we can say. So SQL languages are of these of the following parts, right? Then next is SQL data definition. That is, we have also talked about the data definition language. That is the first part of the SQL. That is the SQL data definition. This says the set of relations in a database must be specified to the system by means of DDL. So set of relations, or we can say the combinations of relation in a database, must be specified into the system or by the system by means of a data definition language. That is the DDL. The SQL DDL also allows specification of not only a set of relations but also information about each relation. That is, how to do the relation or how to maintain the relations, including the schema of the definition. So this DDL, that is a SQL data definition, also includes the schema for each relation, types of values associated with each attribute, then integrity constraint, then set of indices that is maintained for each relation, then security and authorization, physical storage. So we will discuss only the basic things, that is what are the basic types that is available. These are the various basic types that is available in the SQL, that is a char, varchar, int, small int, numeric, real, double, precision. So these are the various, we can say the various basic data types that is also available in the SQL, that is a SQL. So one is the char, one is the varchar, one is the int, then small int, then numeric, that is numeric, then real, double, float. So these are the various, we can say, the data type that is used, that is basic data type that is used in the SQL. Each type may include a special value that is known as the null value. A null value indicates an absent value that may exist but be unknown, or that may exist at all. That is, that may be exist, that not may be exist, that is a null value. The cat data type stores fixed length strings. There is also a provision of the cat data type that also stores the number of fixed length strings that is available. And the varchar, that takes the variable length string, that is also the of the varchar. So there is a char, there is a varchar. SQL also provides the nvarchar type to store multilingual data using the Unicode representation. Then next is basic schema definitions. That is, what are the basic schema definition that is available, or what are the various logical design that is available. That is a basic schema definition. So we can define, or we define an SQL relation by using the create table command. So we use the create table command to show the schema definition, that is a create table command. So this is create table, then the table name, then these are the various fields, these are the various, we can say, the various fields or the various column heading that is available. So there is a table, that is department, one of the heading is department name, that is of varchar type, then building, that is also of varchar type, then budget, that is of numeric type, and this is total digits that is available. Out of this there are two decimal points, so our total is 12 and 2 are the decimal points. So these are the three fields that is available in this table, that is the department name, building, and the budget. And then there is a primary key, which is the primary key out of this. That primary key is the department name. So department name is the primary key. So this says the relation created has three attributes, that is the department name, which is a character string of maximum length 20, building, which is a character string of maximum length 15, and a budget, which is a number with 12 digits in total, two of which are after the decimal point. That is, out of 12 there are 2 points, or there are 2, we can say, the digits that is after the decimal point. The create table commands also specifies that the department name is the primary key of the department relation or the department table. So there is a primary key that is available, that is a department name, that is a primary key, that is a unique key for the table, that is a department. So this is the general form that is available, that is one table, that is R, and these are the various fields, that is A1, A2, and these are the various types of the data or the data types, that is D1, D2, Dn, where R is the name of the relation and AI is the name of the attribute and DI is the domain of the attribute. That is D1 specifies the type of attribute, that is a varchar and the numeric. So what is the type of the attribute that is available? The semicolon shown at the end of the create table specifies that is this is the end of the, or that is the end of the SQL statement. Then this is also defined, that is what is primary key, foreign key, null values. Then these are the various content, that is how to insert the data into the or how to feed the data, or how to give the various tuples, or how to provide the various tuple into the table that we have, into the relation that we have created. So there is an insert into instructor, that is the name of the table is instructor. So insert the values into instructor, and there are values, that is there are multiple values that is available. So one is 10211, that is ID, then name, then department name, then salary. So these are the four fields that is available. First of all, there is the ID of the instructor, then name of the instructor, then department name of the instructor, then salary of the instructor. And there is also a delete command that is also used to delete the tuples or delete the rows from the relation. That is the delete from the student. So that is also a key, or that is also a, we can say the keyword that is used, that is a delete from student. That deletes the, or that deletes the commands. And these are the various examples that we have discussed. That is, there is a department table that is created, course table that is created, instructor table, section table, teachers table. These are the various table, and these are the various fields that is of different types. There is a foreign key, there is a public key, there is a primary key. And if I want to delete the table, whole table, we can either use the delete, or if I want to delete the rows, that is done by the delete, also done by the drop table, that is whole table will be deleted, that is done by the drop table. And we can also alter the table to add the attribute. So if I want to add some column headings or some attribute, that is done by using the alter table command. So we can use the alter then table command, that is used to we can say to alter the table, or to add the attributes, to delete the attribute, that is altering the table attributes. Then basic structures of SQL queries, that is what are the various queries, that is SQL queries that is available. So let's start with this one, that is the basic structures of SQL query. So this says the basic structure of SQL query consists of three classes. So there are three classes of the SQL query that is available in the SQL. One is the select, then from, then where. So first is the select, then from, that is a from which table, and the where. So these are the three clauses, three keywords that is used, that is a select, from, where. The query takes as its inputs the relation listed in the from clause. So whatever the input that is given, whatever the relation that is given, that is listed from the, or that is listed in the from clause, that operates on them as specified in the where and the select clauses. So there are two clauses that is also available, that is the where and the select clause. So one is the from, one is the where, one is the select clauses, and then produces a relation as a result. We introduce the SQL syntax through examples and describe the general structure of SQL queries later. So first of all, there are some basic example, then there is some next example, that is some high level example that is available in the SQL. But the main character is that there are only three clauses that is available, three keywords that is available. One is the select, one is the from, one is the where. So 3.3.1 is querying on a single relation. That is how to query a single relation. So let us consider a simple query using our university example. Find the names of all the instructors. That is, what is the name of all the instructors? Instructors' names are found in the instructor relation. So we put that relation in the from clause. So from means from which relation we can find the result. So one of the clause, that is a select, that is what are the various attribute that is selected. Then from clause, that is what are the various or from which table it is chosen, that is from for the from clause. Then the instructor name appears in the name attribute, so we put in the select clause as I said. So select the name, that is the attribute. So select the attribute name from the instructor. Oh, this is the table name of the table. So this is the table name, that is the instructor, and this is the field name, that is the name. So this is select name from instructor. The result is a relation consisting of a single attribute with the heading name. So what is the result? That is a relation that consists of a single attributes with the heading name. So this result is a single a single attribute will be available, that is a name, that with the heading name. It is shown in the figure 2.1, that is a relation that's result is shown in the 3.1. So that is a table that we have studied in the last class, that is a whole full-fledged table, that is the instructor. And what is the output after giving this query? That is, a name will be selected from the instructor table. Only the name field will be available from the instructor table. So select the name from the instructor table. Now consider another query. Find the department names of all the instructors. That is, what is the department names of all the instructors? So select the department name from the instructor. So whatever the field that we need, that is represented or that is taken out by using the select command, by using the select clause, and then from with the from clause, there is a name of the table that is used, that is the from instructor. Since more than one instructor can belong to a department name could appear more than once in the instructor relation. The result will be displayed in this one. So there are multiple times the computer science will be available, this because more than one persons are available. So there is a duplicate results. Now why there is a duplicate result? Because we cannot apply any we can say the any filtering, that is the duplicate records cannot come. So that's why the duplicate result also come. If I put the where clause, if I put the having clause, if I put the unique clause, that means there is a filtering, that means there is no duplication of the records. But in this is a simple example, that is a find department name from the instructor simply with the duplication, without unique records, without distinct records. We can find any records, n number of records, or all the records, that is done by the select department name from instructor. So if I want to eliminate the duplicates, or if I want to remove the duplicates value, so we can insert the keyword, we can insert the word that is a distinct after the select. That shows the, or that gives the only the unique result. So we can rewrite the preceding queries as follows. So this is select, then distinct, that is distinct means the unique values, that is a department name. So select the type name that contains or displays only the distinct value, that is a unique values from the instructor table. So if I find out this one, then it will duplicates are removed by this one. The result of the above query would contain each department name at most once. That is what is the result of the each query? That would contain each department name at once. SQL also allows to use the keyword all to specify explicitly that duplicates are not removed. So if I use select all duplicate department name, that means the duplicates are not removed. Since duplicate retention is the default, we shall not use all in our example. So this whole crux says if I use select all, that also gives the department name with the duplicates value. If I simply give select department name, that also gives the department name with the duplicate value. So there is no role of the all ALL. To ensure the elimination of duplicates in the result of our example, so if I want to ensure that the duplicate elements or the elimination of the duplicates, elimination of the different or the same values in the result, In our example queries, we shall use the distinct whenever it is necessary. So we shall use the distinct or the same value, or sorry, or the unique value that is available whenever it is necessary, whenever it is required. In the select clause may also contain arithmetic expressions involving the operators, that is a plus, minus, divide, multiply. So the select also contains various arithmetic operations, that is a addition, subtraction, division and the multiplication. That is operating on the constant on the or the attributes of the tuple. For example, this is a query that is available. Select ID, name, department name, salary into 1.1 from the instructor. So select the ID, that is the ID of the instructor, the name of the instructor, then department name of the instructor, then salary into 1.1. So whatever the salary that is available, that is multiplied by the 1.1. So whatever the salary that is given, that is multiplied by 1.1. That returns a relation that is the same as the instructor relation, except that the attribute salary is multiplied by 1.1. So this gives the, or whenever we use this command, so this gives the same relation or the same table as shown in the, or as same in the instructor relation, except that the attribute, what is the attribute, that is a column heading or the field, that is a salary field, is multiplied by 1.1. So everyone's salary is multiplied by 1.1. So this is salary into 1.1. That is, we can also do the, or we can also operate, or we can also use the arithmetic operations within the select clause with the attributes that is available with the select clause. That means this means that we will give a 10% raise for every instructor, or 10% raise in the salary of every instructor. SQL also provides special data types such as various forms of the data type, and also allows several arithmetic operations on these types. That is, there are so many arithmetic operations that is also available, that is plus, minus, divide, multiply. Now next is the where clause. That is, where clause allows us to select only those rows in the result relation from the from clause that specifies the specified predicate or specified condition. So we can use the from clause, we can use the select clause, we can use the where clause collectively. So whenever we use the from clause, that gives the result, that gives the relation as the output, or that it gives the result relation from clause, that satisfies the, or that gives the requirement of the user, that is how to use them, or what are the various criteria that is also available in this one. So if I want to find the names of all the instructors in the computer science department, so if I want that, I want to find the instructors, that is how many instructors are available in the computer science department who have salary greater than the 70,000. Now how to write this query? So that query will be written as this way. That is, result of find the names of all the instructors in the computer science department whose salary is greater than the 70,000. So select the name from the instructor, because what is the field that is we are required? Only the name of the instructors. Now what is the condition, and from which table? That is the instructor table. And what is the condition? That is where department name is equal to computer science, that is the department name is computer science, and their salary is greater than 70,000, not greater than equals to, but the greater than 70,000. That means if a person that have a salary 70,000, that cannot be represented over here, because this is greater than 70,000, not equals to 70,000, right? So this is select name from the instructor where department name equals to computer science and the salary is greater than 70,000. So these are the two conditions that is applied. First of all, this condition is applied on the department name, as well as the condition is applied on the salary. So this is one field that is available, that is a name, and there is a department name, that is also the field, that is also the attribute that is used as a condition, that is used with the where clause, that is where department name equals to computer science and the salary is greater than 70,000. If the instructor relation is as shown in figure 2.1, then the relation that results from the preceding query is shown in figure 3.4. So SQL also allows the use of the logical conventions or connectivities and or not in the where clause. So we can also use the logical operators, we can also use the logical connections like and or not, and the different pipes, that is a less than, greater than, less than, equals to, greater than, equals to, and the double equals to. So we can also use within the where clause. It is not mandatory that only the arithmetic operations are used within the where clause or within the SQL clause, within the SQL statement. No, we can also use the comparison operators, logical connections in the SQL statements or the SQL queries. So SQL also allows to use the comparison operator to compare the two strings. So if I want to compare the two strings, that is also compared by using the SQL statements and the arithmetic operations, as well as the special types such as the data types. So we can also use the logical operators, we can also use the arithmetic operations, we can also use the comparing the strings, that is also available. We shall explore our features in that later in the chapter, that is in detail it is more specified later in the chapter. Now, next topic is queries on the multiple relations. That is, what are the various queries that is available on the multiple relations. That is, queries on the multiple relation means there are more than one table that is available. Till now we have discussed there is only one table, and we have to apply the query on the single table, single relation. Now, next is there is a different queries, there are multiple queries on the multiple relation, that is there are two or more relations, two or more table that is available. So put the queries on the multiple relations. So far our example queries were on a single relation. Queries often need to access information from the multiple relation, that is we are also able to use the multiple relations to find out the or to access the information or to get the information from multiple relations. We now study how to write such queries, that is how to represent or how to write the various queries that is represented, or how to get the various salaries that is able to get or that is able to use the various queries. Now we now study how to write the such queries, that is how to write multiple queries. So as an example, suppose we want to answer the query that is retrieve the names of all the instructors along with their department names and the department buildings. So if I want to find out the instructor names, department building, that is also available. So we are going to fetch the result from multiple queries. So let's take a break right now, then moves to this topic, though this is a lengthy topic. So let's take a break, then moves to the topic that is the queries on multiple relation. That is there are multiple queries, there are multiple table that is used. So how to put the queries on multiple relationship. So or multiple relations, not relationship, that is a relation. So let's take a break right now, then move to this topic that is the queries on multiple relations. So let's take a break right now. Back from the break. Now let's start the session again. So now let's move to the next topic, that is the queries on the multiple relations. That is how to process the multiple queries on the multiple tables on the multiple relations. That is the queries on the multiple relations. So far we have studied about the examples, that is single queries when on a single relation. Queries often need to access information from the multiple relations also. There are multiple relations, there are multiple queries that is available to gather the information. We now study how to write such queries, that is how to process such queries. As an example, suppose we want to answer the query that is retrieve the name of all the instructors, retrieve the name of every instructor along with the department name and the department building name. So how to get the name of all the instructors along with their department name, that is what is the name of their department, as well as a department building name, that is a building name as well as a department name as well as the name of all the instructors. Looking at the schema of the relation instructor, we realize that we can get the department name from the building department name or from the attribute department name. So we can get the department name from the department table, but the department building name is present in the attribute building of the relation department. To answer the query, each tuple in the instructor relation must be matched with the tuple in the department table whose department name value matches the department name with the value of instructor tuple. So in this we are using two tables, that is the instructor and the department, that is also used for the query processing that is also used in the query processing. So in SQL, to answer above query or to answer these queries, we list the relations that need to be accessed, that need to be taken place in the from clause or the from clause. So in the from clause we have chosen, or we have to choose the multiple relations, multiple table that is also used, that is also getting one data, that is getting the various data that is available in the multiple forms, and specify the matching in the where clause. To above the above query can be written in SQL as follows. So how to, or what is the query that is available, or what is the tool that is available. So the above query, that is how to get the all the information or name of from the instructors, where the department name is the same or the department number is the same, that is the values will be taken from the department relation. So select the name instructor.department name building. So getting the name first of all, and then instructor.department names, that is the department name of the instructors as well as the building name of the instructors. Then what are the two tables that is used, that is the from instructor and the department. So there are two tables that is also available, one is the instructor table, one is the department table. Now what is the condition, where the instructor.department name equals to department.department name. So what is the condition, where the department name of the instructor table is similar to the department name of the department table. So there where instructor name is the same as well as the department name is the same. So if the instructor and the department relations as shown in figure 2.1 and 2.5 respectively, then the result of this query is shown in the figure 3.5. So you simply get how to get the name, how to get the department name, and how to get the building name from various departments or from two relations or the two tables. Now, what is the condition, where the department name of the instructor is equals to the department name of the department. Note that the attribute department name occurs in both the relations, that is the instructor and the department. So department name is a field that is available or that is represented in both the relations. In both the relations, what are the two types of relation in which the department name is available? That is the instructor and the department. So there are two relations, or there are two table that is available. One is the instructor, one is the department, where the department name occurs. So we have to combine the department name, or we have to check the condition for the department name, and the relation name is used as a prefix in the instructor.department name and the department.department name. So this is the department name, this is the building, this is the name. Here the department name is same for the instructors as well as the department. In contrast, the name and the building appears in only one of the relation, and therefore don't need to be prefixed by the relation name. And this naming convention requires that the relations that are present in the from clause have distinct names. Now we consider the general case of the SQL queries involving multiple relations. That is, the general cases means simple cases of the general, that is the most commonly used SQL queries having the multiple relations, having the multiple tables. As we have seen earlier, an SQL query can contain three types of clauses, that is the select clause, that is the from clause, and that is the where clause. So there are three types of clauses that is generally used, that is the select, from, and the where clause. The role of each clause is as follows. So what is the role of each clause? Let's discuss. The select clause is used to list the attributes desired in the list of a query. So all but queries, or all but attribute that we need, that we describe, or that we give in the, or that we express, or that we explain in the select clause. That is, the select clause is used to list the attribute. List means to display the attribute that is desired, or the attribute desired in the result of a query. So what are the attribute that is required in the result, or in the output of a query, that is done by the select clause. And the frame clause, that is a list of the relations to be accessed in the evaluation of the query. So what is the role of from clause? That is, what are the various relations, what are the various table that need to be accessed in the evaluation of the query. Then where clause, that is a predicate involving attributes of the relation in the from clause. That is, where means the checking the condition, or checking the attribute, or checking the condition involving attribute of the relations, or what are the various attributes of the relation in the from clause. And a typical SQL query has the form, that is a select multiple attributes from multiple tables relations where there is a condition that involves attributes of a relation in the from clause. So there is a where clause also for representing the information. Each AI represents an attribute and each R1 represents a relation. P is the predicate, that is the P is the condition. If the where clause is omitted, the P is true. Although the clauses must be written in the order, that is a select from clause, that is first of all there is a select, then there is a from, then there is a where. But the easiest way to understand the operation specified by the query is to consider the clauses in the operational order. That is if I want to get the query, or simply fetching the query, or simply understand the query in an understandable manner, in an efficient manner, then we use the order as a first from clause, that is from which table, then where clause, that what is the condition, then select clause, that is what are the attribute that is selected, that is done by the select clause. The from clause by itself defines a Cartesian product of the relations that is listed in the clause. It is defined formally in terms of set theory, but is perhaps best understood as an iterative process that generates the tuples for the evaluation, or for the result evaluation or relation of a from clause. So in the set theory, it is understandable that it is an iterative process, it is a routine process that generates the tuple for the relation, that generates the rows for the relation, or result, that is a relation of the from clause. So for each table Ti in a relation, for each table T2 in a relation, for each table Tm in a relation, concatenates the T1, T2 till Tm into a single tuple T and add the T into the result relation. The result relation has all the attributes from all the relations in the from clause. That is, what are the various attributes that is available, or what are the various tables that is available, that is the result relation has all the attributes from all the relations in the from clause. Since the same attributes name may appear in both R1 and the Rj. We saw earlier, we prefix the name of the relation from which the attribute originally comes. So we give the name where instructor.department name, where department.department name. So we have to specify the attribute as well as the table name using the dot operator. For example, the relation schema for the Cartesian product of relation instructor and the teachers is as follows. So what is the Cartesian product that is available? That is the instructor.id, instructor.name, instructor.department name, instructor.salary. These are the four fields that is available from the, that is getting from the instructor, that is ID, name, department name, and the salary. And what are the various attributes that is available from teachers table? That is ID, course ID, section ID, semester, year. So these are the five attributes that is also available from the teachers table, that is ID, course ID, section ID, semester, and the year. With this schema, we can differentiate instructor ID from the teacher's ID. From those attributes that appears in only one of the two schemas, we shall usually drop the relation name prefix. That is instructor.id, name, department name, salary. That is because one dot is also safe for solving the, or for giving the, or for getting the result from the query. That is the instructor.id instructor.id, name, department name, salary. That is ID, name, department name, and the salary are taken from the instructor table. In the same way, there are five attributes that is also available, that is ID, course ID, section ID, semester, year, that is also from the teachers table. That is also the five attributes are available for the teachers table. So this is instructor.id department name, salary, then teachers.id, course ID, section ID, semester, year. To illustrate, consider the instructor relation and the teachers relation in figure 2.7. The Cartesian product is shown in figure 3.6. So these figure 2.1 and 7, that is a figures, that is a table that is available in 2.1 and the 7, and that I will have shown yesterday. That is, there are multiple instructor tables or instructor fields, there are multiple department fields, there are multiple teachers field that is available. For each tuple in the instructor, is combined with every tuple in the relation. So if I want to find the Cartesian product, that is every tuple, that is every row from the instructor will be matched or will be combined with every row in the teaches table, or every tuple in the teaches, even those that refers to the different instructors. The result can be extremely large relation, and it's rarely makes sense to create such a Cartesian product. So what is the result? That is extremely a large relation, and it makes sense, or it is a good idea to create such a Cartesian product. What is a Cartesian product and how to create a Cartesian product? In practice, SQL may convert the expression into equivalent form that can be processed more efficiently. However, we can defer the concern about efficiency in chapter 12 and 19, or 12 and 13. So this is the instructor ID, that is the instructor.id, that is this ID is taken from the instructor table. Then there is a name, then department name, salary. This is the ID from the teachers table. Then there is a course ID, section ID, semester, and the year. So this is the combination of the both the table, that is a Cartesian product of all the tables, both the table, that is the instructor and the department. So first 4 fields is from the instructor table, and next 5 fields is from the department table. Instead, the predicate in the where clause is used to restrict the combination that is created by the Cartesian product to those that are meaningful for the desired answer. We would expect a query involving instructor and the teachers to combine a particular tuple T in the instructor with only those tuple in teachers that refers to the same instructor to which the T refers. That is, there will be a combination of the both the instructor and the teachers. If some data is common, that is, if there is some tuple that is common, that is also refers to the same instructor in which the T refers. That is, we wish only to match teachers tuple with the instructor tuple that have the same ID value. The following SQL query ensures this condition and outputs the instructor name and the course identifiers from such matching tuples. Now select the name and the course ID, that is, what is the name, what is the course ID, and then from instructors and the teachers, from both the table it is using, where instructor ID is equal to course teachers.id, where the ID is same. So find out the name and the course ID. Note that the above query output only instructors who have taught some course. Instructors who have not taught any course are not output. If we wish to output such tuple, we will use an operation, that is the outer join. So we can join the output, or we can use the output with the outer join. This is the next query, that is select the name and the course ID. So display the name as well as the course ID from both the tables, that is the instructors and the teachers, where instructor.id equal to teachers.id. That is where the instructor.id, that is the ID of the instructor, is equal to the teacher or ID of the teachers, and the instructor.department name equals to computer science. So there is an AND condition, that means both the conditions are true. First of all, the ID is also matching, and then the department name is the computer science, and display only the name and the course ID. Note that since the department name attribute occurs only in the instructor table relation, so we could use department name instead of the instructor.department name in the above query. This is the answer that is available. So what is the meaning of meaning of SQL query that is understood? So generates a Cartesian product of the relation that is listed in the from clause, then apply the predicate, apply the condition that is available in the where clause, then for each tuple in the result of step 2, output the attributes that is specified in the select clause. The above statement or above sequence of steps helps make clear with the result, or what the result of an SQL query should be, not how it will be executed. This is what is the result, not how the result will come. That is the main, we can say, the main clarity between the result of a query and not how it is executed. Now next is natural join, that is how to join the multiple table, or how to merge multiple table, that is a natural join. So in our example query that combines, or that combine information from the instructor and the teachers table, the matching condition required instructor.id, that is equal to the teachers.id. So this is the condition that we use, that is where instructor.id is equals to the teachers.id. These are the only attributes in the two relations that have the same name. So this is the only attribute, or this is the only field that is same for both the fields. What are the two fields, or what are the two tables that is same? That is the instructor.id and the teachers.id. These are only attributes in the two relations that have the same name. There is no other relation that have the same name. In fact, this is a common case, that is a matching condition in the from clause most often requires all attributes with matching names to be equated. That is a matching condition that is available in the from clause that requires all the attributes with the matching name to be equated. To make the life of an SQL programmer easier for this common case, so to make the SQL programmer or life of SQL programmer very easy, SQL supports an operation known as the natural join. So SQL provides an operation that is known as a natural join, which we describe below. So now, what is a natural join? So to make the life, or to make, or to combine the various tables, to combine the various attributes of multiple tables, so we can use the natural join. In fact, SQL supports several other ways in which the information can be joined together. We have seen a Cartesian product along with the where clause can be used to combine multiple relations. Now, what are the other ways that we discuss in section 4.1? So, first of all, what is the meaning of the natural join that combines multiple tables? This says the natural join operation operates on two relations. So there are two relations that is available. The natural join operates on the two relations and produces a relation as a result. So it operates on two relations, that combines two relations, join two relations, and produce a relation as a result. Produce a single relation as a result. Unlike the Cartesian product of two relations which concatenate each tuple of the first relation with every tuple of the second. So when we use the Cartesian product, one tuple of first relation, that is the first row of first table, must be matched or must be concatenated with the every table of the, or every row of the second table. So first row of one table of the first table is matching with, is concatenated with every row of the second table. In the same way, second row of first table is concatenating with every row of the second table. In the same way, third table of the first row of the third table is matching with every row of the second table. So natural join consider only those pairs of tuple with the same value on those attributes that appear in the schema of both relations. So going back to the example of the relations instructors and the teachers. Computing instructors natural join teaches, that is the instructor and the natural join are combined, that is a natural join. Consider only those pairs of tuples where both the tuples from the instructor and the tuples from the teachers have the same value on the common attribute, that is the ID. So find out the values, find out the tuples from the instructor and the tuples from the teachers. So find out the rows from the instructor and the teachers but have the same value on the common attribute. What is the same value? That is the ID is the same value. That's why we combine the ID and the ID of the instructor, ID of the teachers. This is the ID, this is the name, department name, salary, courses ID, section ID, semester year. This is the natural join of the instructor table with the teachers relation. The result relation that is shown in figure 3.1 has only 13 attributes, the one that gives the information about the instructor and the course that the instructor actually teaches. Notice that we do not repeat those attributes that appear in the schema of both the relations. Rather, they appear only once. So there is no duplicate record, there is no duplication of the record, there is no repetition of the record. Notice also the order in which the attributes are listed. First, the attributes are common to the schema of both the relations. Second, those attributes unique to the schema of the first relation. And finally, those attributes unique to the schema of the second relation. So there are multiple attributes that is common to the that is unique to the schema of second relation. There are multiple attributes that provide the schema of the first relation. Consider the query. What is the query? For all the instructors in the university who have taught some course. So find out all the instructors, or for all the instructors in a university who have taught some course, find their name and the course ID of all courses they taught. So what are the various instructors that is available in the university who have taught the same course or who have taught some course? and find out their names as well as the course ID of their courses that they taught. Now, which we write earlier as select name course ID from the instructor and the teachers. So getting the attribute that is a name, that is a course ID, from the two tables, that is a instructor table, that is a teachers table. Now what is the condition? Where instructor.id is equals to the teachers.id. So getting the ID from the instructor as well as getting the ID from the teachers, and where IDs are equal, so find out the name as well as the course ID. This query can be written more precisely or more concisely using the natural join operation in the SQL. Now, what is the query that is available? That is select name and the course ID from instructor natural join teachers. So instead of writing this one that combines with the use of the ID, or that combines with the use of the same field that is the ID, we can also use the statement that is a select name course ID from the instructor table, that is naturally joined, or every field of every attribute of the one table must be joined with another table. That is a where there is no where clause, only select name and the course ID from the instructor. There is a natural join teaches. Both of the above queries generate the same result. So as we saw earlier, the results of a natural join operation in a relation. So what are the result of a natural join operation? That is a relation. Conceptually expression, instructors natural join teaches in the form from clause is replaced by the relation obtained by evaluating the natural join. The where and the select clauses are then evaluated on this relation. So what are the where clause, what is the select clause that is evaluated on this relation? A from clause in a SQL query. So what is a from clause that is available? That is a from clause that is also available in the SQL query. Can have multiple relations that is combined with a natural join as shown here. And this is select A1, A2, AN. So select the A1, A2 until AN. From R1, that is select the row attributes from the row that natural join with the R2, that natural join with the R3, that natural join with the R4, and there are n number of rows that will be joined by using the natural join. Where P, now P is a condition that is also available. So more general, a from clause can be either of the form. This is from E1, E2 and the EN, where E1 can be a single relation or an expression involving natural join. For example, suppose we wish to answer the query, list the name of the instructors along with the titles of the courses that they teach. So what is the title of the courses that they teach? The query can be written in the SQL as follows. So what is the query that is written? That is what is the list of the names of the instructor along with the title of the courses. So select name, title. So two fields are used, that is the select the name or getting the name and the title from instructor, that is the instructor table. Natural join teaches. So instructor and the teachers are joined, and the course, then instructor will be combined with the teachers and the course, where teachers dot course ID, that is the course ID of the attribute teaches, and the course ID of the table, that is a course, must be matched or must be compared with each other. When they are equal, then provide the name and the title with combination of the instructor and the teachers and the course table. The natural join of instructor and teachers is first compared as we saw earlier, and the Cartesian product of this result with the course is computed, from which the where clause extract only those tuples where the course identifier from the join result matches the course identifier from the course relation. Note that the teachers.course ID in the where clause refers to the course ID field of the natural join result, since this field in turn came from the teachers relation. In contrast, we can also use, in contrast, the following SQL statement does not compute the same result. So if I want to join natural join three table, that does not provide the same result. and to provide the benefit of natural join while avoiding the danger of equating the attributes erroneously. SQL provides a form of the natural join construct that is allows you to specify exactly what column should be equated, that is what are the various column that is required, that is represented, that feature is explained by using the query. That is select the name and the title, that is select the name as well as the title attribute from the table where instructor natural join teaches, that is where instructor is joined with the teaches. There is a join, that is a course using course ID. The operation join using requires a list of attributes come to be placed, that is what are the various attributes that comes to be placed. Both the input must have attribute with specified names. Therefore, in the preceding SQL query, the join construct permits teaches.department name and the courses.department name to differ. So there is a difference between the department name from the teacher or teachers table and the department name from the course table, that is differ, and the SQL query gives the correct answer. Now the next query is, or the next topic is additional basic operations, that is what are the additional operations that is also available in the SQL. So first of all, there is a binary rename operation, then addition operation, string operation. So there are multiple operations that is available with the SQL queries. So I'm not going to start this topic because this is a lengthy topic and there is no time left. So that's all for today's session. Thank you so much everyone for listening me. If there is any doubts, any confusion, anything that you want to ask, anything you want to clarify, any suggestion you want to give, you can give the suggestion, clarify the doubts, clarify the any problem that is you have. So in the next class, that is to Monday's class, we will be discussing a next topic, that is additional basic operations of the SQL. That is the basic operations of the SQL. What are the additional basic operations that is available in the SQL? We have studied so many basic operations in the today's class, in the tomorrow's class. What are the additional basic operations that is available in the SQL? So let's stop our class over here only. In the Monday's class, we will bring you a next topic, that is basic operations on the SQL, additional basic operations, right? So that's all for today's session. Thank you so much everyone for listening me. Bye bye.